announcements. Yeah. No, do not do this. First, I want to introduce Marty Fitzpatrick, who is a volunteer. He's in the back of the room, and he'll be here most all days for at least a little while, possibly longer. Marty has experience with all sorts of science. He worked for USGS, he was affiliated with OSU, and he's now retired and is here because he likes the idea of working with young people to help them explore science. So one of the things that you can do today that would be really great when you have time to go outside and do some investigating is take a couple minutes, introduce yourself to Marty. He has no idea what specifically we've been doing in the class. He knows environmental science, but I've given him the rundown of the work that we've done prior to today. So you could even give him a quick recap of like, oh, well, we started by looking at this, and we learned this, and we talked about this, and et cetera, et cetera. And then tomorrow, so the brief announcement for tomorrow is I'm not going to be here. I made a command decision to take tomorrow off because I'm really behind on grading, including the tests, and I need a day. I just need to like have an entire day to get all that work done. So I'm not going to be here tomorrow, and Ms. Jackson probably won't be here. If she is here, it'll just be for a couple minutes. So what would be great is if you all could be kind and patient and understanding with the sub, whoever that might be, and I'll try to put something together for you that is at least reasonably interactive and enjoyable. And then, so for the next several weeks, we're going to be looking at water quality, and water quality is something that a lot of people have an intuitive idea, like water quality, right? Like how hard is that? But it turns out water quality is actually super interesting and super complicated. And one of the reasons that it's really complicated is that there is not any one simple way of evaluating water quality. And that's what we're going to talk about this morning, just for like 7 or 8 minutes, not even 10 minutes. As we move forward with this work, I'm going to have you all working in small groups for just be for a few weeks while we investigate water quality. You'll be working in work groups, and my hope is that I'll have you working with somebody that I think you're pretty comfortable with, and I'll try to have you working with somebody that maybe you don't know so well, with the idea being that without any discomfort, you get a chance to interact with some other people in the class and maybe get to know some people that you wouldn't otherwise get to know. All right, does anybody have any questions before we start with water quality? All right, so what I'm going to do, and it's been a while since I've kind of led an official note-taking session, so I'll just remind you that what I do is I'll just underline the stuff that you need to write down. So you don't have to worry about copying down everything that you see. All you need to do is just make sure that you write the things that I underline. So you can put this in as kind of the title for the notes, what is water quality? And what we're going to look at today is just an introduction, just a brief outline of the kinds of things that people look at when they think about water quality. But I'm also going to present to you the big misconception, because there is one, and it's really kind of neat to think about, and we'll explore it in a little bit more detail when we start looking at the water quality of our creek. So the first question is, what is water quality? So I want you to take 30 seconds, and with 1 or 2 people near you, see if you can come up with a 1-sentence description of what water quality is. Are you ready? Go. so I'm gonna ask for some feedback from specific people because I heard some specific things. So, Michael, you said a couple of things that I overheard. Will you share one of them?
So something about like oxygen.
Okay, so there's measurements, right, involved, like oxygen, how much oxygen is in the water, yeah. Desi, I don't know what she said, but you said, oh, that's good. I don't know what she actually said. Do you remember what she said?
I talked about the school fountains, like the big and like red.
The for okay to drink, not okay to drink, yeah, perfect. We have labels on like water, like faucets in the school that say, do not drink. So that's something to think about. And then David, you said something too, I think you said, did you say minerals?
He said minerals.
You said minerals, Cooper, yeah. So what do you mean, like,
I don't know.
have you ever bought bottled water and seen that sometimes it has ingredients besides water in there? Yeah, I mean, water, like, isn't just water usually. There's other stuff in there, we can't see it, but that doesn't mean it's not there, yeah. So that's really good. What we're gonna use for our definition is, this is kind of the sciencey definition, but we'll dive into this and have it be something that we're more familiar with and more fluent with. But basically what water quality does is it describes the characteristics of water. And there's two kinds of characteristics that we care about in biology. Physical characteristics, which are things like temperature, you already know what temperature is, and then turbidity, which is like its cloudiness. So some of you probably have already seen the creek today. It's kind of like, it's a little hard to see down to the bottom, so it's relatively turbid. And then there's chemical characteristics, and when we were looking at soil, we measured pH with the pH strips. So that turns out that we can measure pH of the creek water or of drinking water or of ocean water as well, right? So this is gonna be our working definition, a description of the physical and chemical characteristics of water. And if you think about it, it's kind of like, that matches up with what you said, right? Because we had an oxygen, we had a sticker, watch out for the sticker. Do you remember what the deal is with the sticker? What are they worried about? Does anybody know? Does it say? Oh no, it doesn't say. Does anybody know what we might be worried about in drinking water? In an old building like this one? Lead, yeah. So that's that's a thing in water, right? It's a chemical that's in water, yeah, and then minerals, same deal. When we look at water quality information, it will tell us something, right? Like if we think about any kind of scientific concept, it's designed to communicate information. What is the kind of information that we would see with water quality? What sorts of things, if I had a sheet of paper that described the water quality of our creek, what do you think that would look like? So again, take 30 seconds and talk, see if you can come up with some ideas.
Types of insects
Okay, so I heard a few different things, and I already forgot who said them, but I think Pei and Niku, one of you said something about clean or dirty, right? Did you say that? What did you mean by clean or dirty?
Like, you could see how, like, clean would be, like, there's some, like, organisms in water that only will live in, like, good quality water, so, like, cleaner, and then others would live in dirtier water, so, like, something like a swamp or something,
Okay.
and then clean water would be, like, something out of a sink or something.
That's perfect. Okay, so what she said was there's clean and then there's dirty, and that really refers to the appearance of water. But that doesn't necessarily mean that it's like good or bad. Like there are some organisms, she brought up a swamp, for example. swamps might look really dirty, but, I mean, there's lots of organisms that live in swamps, and maybe they like it like that.
I was gonna say a good example of that could be still water. Still water can look really clear, but it actually is full of bacteria.
There could be things in the water that we can't see, and that might not mean that it looks visibly dirty, but that sure means we probably wouldn't wanna drink it. We've got actually, like, Mel talked about drinking water, Pei talked about like wildlife. What's that? Let's see, there was somebody else who said something and now I'm blanking on what it was. What you said, I think I overheard you guys saying something, I can't remember what it was.
Like how safe it is or like where it came from.
Safe, to do what with? To drink. So we've got this idea of like, well, safe, what is safe? I mean, like, is our creek safe?
No.
Not to drink, but how many of you have like splashed around in it? Raise your hand. Are you okay? Yeah?
Actually got a break. Trevor.
Yeah. Yeah.
Last 2 summers ago, me, him, and Mason, we were
that's
swimming in
funny.
a river, and he
Yeah.
got a brain eating the beaver.
Oh, yeah, that explains it.
Yeah. Trevor, he's really stupid now.
Yeah, I have that same
I
problem.
actually saw him and Marcus and Trevor Mason in your class last week,
Yeah.
running around outside throwing mud at each other.
That sounds about right. So here's what's really cool about water quality is that when we talk about water quality, we have to think about some sort of particular use. It doesn't make sense to say the water is safe. It doesn't make sense to say the water is dirty, because it might be safe for swimming, but not safe for drinking. It might be too dirty for us to want to drink it, but it might be perfectly fine for an alligator or a catfish that lives in it. And you don't have to write these things down, but it probably makes sense to you just looking at this. It's like, oh yeah, of course, different kinds of fish and wildlife might have different preferences for water. Even our pets, like how many of you have a dog and that dog is like just walked up to a puddle in the street and just, right? That is the grossest water you can imagine. It's absolutely disgusting, and they're just like, let me at it. They don't care. So different uses have different ways that we evaluate water quality, and so what this means is that one of the really common ways that we describe water quality is by using the words good or bad, but we can't really do that. We can't just say the water quality is good or bad. We have to say it's good for some particular use, or it's bad for some particular use. So a couple of examples that are interesting to think about. It's really salty water. Like we wouldn't want to drink it. And trout, if you are somebody who likes fishing or knows a little bit about fish, trout don't like real salty water, but sea stars do, and ocean fish do. They really like salty water, like that's their thing, and if you put them in an environment that's not salty, they don't do too well. So it's not so much that salty water is good or bad, it's that it's good for some things and it's not great for other things. Another example are the thermal pools in Yellowstone National Park. Has anybody ever been there? Pretty amazing, huh?
Did you swim in that?
Well, no. So these thermal pools are usually hot enough that they would sort of boil you. If they're not hot, they may or may not have chemicals or organisms in them that would hurt you. So it might be safe, but people die every year at Yellowstone National Park by going into these springs. So you have to be really careful. But it's usually the heat that's the
You
issue.
like dip your feet in?
It depends on where you are. You're not supposed to in these areas because every time humans interact with this kind of a sensitive ecosystem, we make it worse. But if you like, there are natural hot springs in the Pacific Northwest, and people hang out in those all the time, and it won't hurt you. Yeah.
Those hot springs in Yellowstone, if you were to dive into them, would burn your whole body.
They might, yeah, different. So that's where this very, very high pH. Remember when we talked about pH and I said that it tells you about the reactivity. So things that have a really low or a really high pH are really reactive. And yeah, you can literally melt your flesh away with something that has a real high or a real low pH. But there are organisms that live in here, and these colors are made by the organisms that live in these pools. So one of the things that we're gonna try to explore is like, well, when we collect data to try to evaluate the quality of water, we have to make sure that we know what use we're evaluating the water for. Wildlife, is it drinking, is it swimming? Even different kinds of wildlife might have different preferences, so we'll kind of come up with some working ideas about how to do that. All right, so that was just kind of the idea here was to just get you thinking about the complexity of water quality, because most of the time people have an instinctive just like, oh yeah, that's pretty straightforward, but it's actually not. It's pretty complicated. And what I'm going to ask you to do next is you can take one of these. You just take one and pass it down. I'm going to ask you to work in partners to do this outside. We have about 25 minutes left. What I want is for you to spend a solid 20 of those 25 minutes outside making visual observations. And I'm gonna just tell you, so these are all things that you'll be able to you don't need to know like a lot of information to start with in order to be able to understand this stuff. But I do want you to think about a couple of things. One is the pipes and drainage, like drainage openings. There are actually tons along the creek. So what I want you to look for specifically are places where, when you look at the creek, what you see on the bank is like an actual pipe just coming out of the ground and going into the water. Or in some cases, it's a big concrete, like it looks like a tunnel almost. And they're really hidden because they're along the banks of the creek, and there's a lot of vegetation that grows over the top of them, but they're all over the place. So I want you to think about those things, where they come from. And then there is this number 2 where it says non-point source pollution. So that is stuff that can get into the water that was not put in any one specific spot, but it's kind of put all over the place. So think about the fact that this is a school, and we have lots of grass and sports fields and things like that. What kinds of things might they put on those sports fields? And if they like spray something on the fields and then it rains, what happens to that water? And does it carry any of those things with it? So those are the kinds of things that you can look at. When it comes to physical evaluation of the water, there's that's number 5. There's 2 things there: estimating the water temperature and an odor. And you can actually, if you want, dip your finger into the creek to estimate, and you can grab a little bit and smell it. But 2 things to keep in mind. One is the water's pretty high because it rained a lot over the last 12 hours. And so be careful. If you end up muddy and wet, there's not much I'm going to be able to do to stop it. And more importantly, if there's places where the water's moving quickly, it's not safe. So be really cautious. Only approach the creek in places where you know that you have stable, solid footing. And then don't drink the water. And if you do touch it before you eat anything or drink anything else, make sure that you wash your hands with soap and water. Yeah.
Are we doing this on this piece of paper?
Yeah, you can do it right on this piece of paper. We've got our what do you call them, clipboards in the cabinet. And so let's see. Well, it'll be about I want you back here at 11:40 so that we have time to take pictures and turn things in. All right.